So let's talk about the idea of geometric progression. We're going to start with a simple example. So unlike arithmetic, you have a constant difference. Geometric progression, you have a constant ratio. So let's say I give you a simple number sequence like 5, 20, 80, 160, 320, and so on. So this sequence, you can see there's a constant ratio here, right? So in this case, you can see you times 4 times 4 times 4. All right, now how do you show, working wise, how do you show that this is geometric? So we say the second term t2 is 20, you divide by the first term t1, you get 5. This ratio is 4. If I take t3 divided by t2, 80 divided by 20, you also get 4. Now if I can show t2 over t1 has the same ratio as t2 over t2, therefore this is a geometric progression with we use the symbol r. R stands for common ratio, and my common ratio is just 4. Now your common ratio can be more than 1, can be less than 1, can even be negative, but it cannot be 0. If your progression is 0, for example, if you let's say we start with a number like 6, if your common ratio is 0, the next number is 0, 0, 0, which doesn't make sense. Your common ratio cannot be 1. If your first term is 6, then you get 6, 6, 6, 6. So you're not actually making progress. It's not a progression. But it can be less than 1, it can be negative. Now, classic example, maybe I give you an example of fraction. So let's say you have 162, 54, 18. So in this case, your common ratio, if I take t2 divided by t1, 54 over 162, you get 1 over 3. If I take t3 divided by t2, 18 over 54, you also get 1 over 3. So it's also a geometric progression with a common ratio of 1 over 3. Now generally we take the first term as a, and we use the symbol r for common ratio. So you multiply by r, second term is ar, next term is ar square, you keep multiplying by r, right? So if t1 is a, t2 is ar, t3 is ar square, t4 is ar, and ar3, if tn it will be arn minus 1. And notice the power for r is always 1 less than the power for the number of terms n. So example, if I want to find, let's say I have a sequence 64, 96, 144. My first term is 64. My common ratio is 96 over 64. This will be 1.5 or 3 over 2. So if I want to find, let's say the seventh term, we'll take a, r, 3 over 2 or 1.5 up to you, power 6. Power 6. This one you can cancel, a nice number. 3 power 6 is 729. 2 power 6 is 64. You cancel them, 729. Obviously, you can use a calculator. Don't have to count manually like this. Okay. So, what if I know specific terms? Okay, let's say I know that, okay, let me clear this. I know my first term is, I'm going to use 6. All right, let's say next one is 12, next one is 24, all the way until 768, and I want to find how many terms I have. All right, so we can use the formula. A is 6, r is 2, my tn is 768. So we say a r n minus 1 is 768. Now you cannot times the 6 inside. Instead, you got to divide by 2. Divide by 6. 768 divided by 6 will give us 128. Now, we know 128 is 2 power 7. So, by comparing, we know n should be 8. Right. Now, also, we have something called geometric mean. What is a geometric mean? Now, if you have 3 consecutive terms of x, y, z, we know y over x will give us the same ratio as z over y. So your y square is xz, y is the square root of xz. So let's say I have 3 consecutive terms of, I'm going to use 2x and 18, right? The middle term is actually the square root of the other 2 terms multiplied together. In this case, square root of 36 is just 6. Another example would be this. Let's say you have 3 consecutive terms, x minus 3, x plus 1, and say 4x minus 2. These are 3 consecutive terms of geometric progression. So we know we can use t2 divide t1 equals t3 divide t2. So we can cross multiply and expand this. So let's say I expand 2x plus 1. This will be 4x squared minus 12 minus 14x plus 6. Rearrange it, bring everything over. 14, 16x, this will be 5. You get 15 and 1. 15 and 1. So x is either 1 over 3 or 5. Okay, so if you want to find a common ratio, for example, you can sub inside. Let's say all my terms are positive. Sometimes they will say all terms are positive. If all terms are positive, you have to ignore 1 over 3. Why? If you take 1 over 3 and sub inside here, you get negative. So let's just say that we take the positive value, x is 5, right? So when I sub inside, my common ratio will be t2 divided t1, which is 5 plus 1, 5 minus 3, 6 divided by 2. My common ratio is just 3. Okay, now let's say I want to find the nth term. Maybe you have a progression like this, 54, 36, 24. Now you want to find the first term that is less than 1. This thing is going to go smaller and smaller. At one point, you'll be less than 1. So my A is 54. My common ratio is 36 over 54. This will be 2 over 3. Now my Tn is less than 1. So remember Tn formula is ARn minus 1. So we take 54, 2 over 3, n minus 1 less than 1. You can divide this. Now unlike the previous example that I've given you, you cannot compare and say n equals to something from here, because 54, 1 over 54, you cannot write this as 2 over 3 power something. Now you have to use logarithm. Now I hope you relearn in logarithm, the laws of logarithm, the third law, the power law. We can bring the power down, right? And then here we can divide it. But one thing about logarithm, if your y value is between 0 and 1, you log y, they're always negative. So how does this affect your answer? Your symbol has to change. So you want to use your calculator, log 1 over 54, divide log 2 over 3. Whatever you get, you plus 1. Log 1 over 54. Use a calculator, 1 over 54, divide log 2 over 3. Then you plus 1. I got 10.84. If n is more than 10.84, my n should be 11. Okay? Alright, now let's talk about solving simultaneous equation. Yeah, I'll just go through two questions. Let's say you have a geometric progression such that the fourth term is 135 and the seventh term is 3645. I want to find the first term A and the common ratio R. Now the fourth term we can use ARn minus 1, which is AR3, first equation. The seventh term is ARn minus 1 will be, let's make it the eighth term. Okay, like the seventh term will be better. 6, 3, 6, 4, 5. Okay, so I'm going to take this equation 2 and divide by equation 1. So when you divide here, AR6, AR3, in arithmetic progression, we always plus and minus to get rid of one unknown. In geometry, we're going to divide. So because when you divide this, we can actually cancel out your A. And if you simplify your R is power 3 here. So 3, 6, 4, 5 divide 135. I've got 27. So cube root of 27 is 3. Now you want to take this and sub inside, let's say, equation number 1. Your A, 3 power 3, 135. That is 135 divide 27. Your A is 5. Okay. Now, sometimes the question may not be so straightforward. Let's say they say that we have a geometric progression such that the difference between the first two terms, okay, I'm not going to write down words, I'm just telling you the difference between the first two terms, the first term and the second term, or should I say the first term is greater than the second term by 16, and the fourth term is greater than the third term by 9. So here we have to use A minus AR. Remember, T1 is A, T2 is AR, equals to 16. T4 is AR cubed, T3 is AR squared. This is now 9. Now, how do you simplify this? We can actually take out A, left with 1 minus R. This is your first equation. Here, the second one can take out AR squared, left with R minus 1. Okay, I think it's d3 minus d4, not d4 minus d3. Yeah, sorry, should change this to d3 minus d4. Yeah, because the term is getting smaller, not bigger, right? So this will be d3 minus d4, which is ar square, ar4, ar3. So we take out ar and square, you get r minus 1. 1 minus r, sorry. 1 minus r. So this will be a second equation. So we will take equation 2 divide equation 1. So ar square divide 1 minus r divided by a1 minus r is 9 over 16. As you can cancel, r square is 9 over 16. When you square it, you get 2 over 3. 3 over 4, sorry. Take this and sub inside any equation. Maybe I sub inside equation 1. Right? My a, 1 minus 3 over 4 is 16. A should be 16 times 4, 64. Okay, that's all for the first part, the general term of arithmetic progression.